Good day, good day, good day. Welcome back to our YouTube channel. So if you're new here, welcome. My name is Stiffler and I'm the one that is going to be helping you throughout if you decide to join us. So if you decide to join us, please show this by subscribing to this channel. And I promise you, you won't regret this. So today we are on momentum. And we are going to break momentum in 4 lessons. So lesson 1, we'll be talking about just the momentum, change in momentum, and Newton's second law of, in terms of momentum, right? Newton's second law in terms of momentum. So also we include just a bit of questions just to solve, just to show how this works. And then lesson 2, we're going to be focusing on conservation of momentum, elastic and inelastic collision. So this second part we'll be talking about these 3 things, right? And then lesson number 3 we'll be talking about impulse momentum theory, right? And also just because impulse and momentum theory is a small section, I'll also be talking about the breaking down of this whole topic. So it means that I'm going to redo this whole topic as a summary, in a form of a summary way, right? After doing impulse and momentum theory. And then lesson 4, I'll post it the following day, which lesson 4 will focus mostly on solving the exam questions. So I'll cut some other question papers just focusing on momentum. So I'll take all the questions that will be focusing on momentum and I'll post them on my Google Drive, and the link of this Google Drive, I'm going to leave it in the description of this video. So if you just want the document on those momentum questions, just go to description and the Google Drive and you see these questions. I hope we are going to have a good time, and I hope we are going to enjoy each other's company throughout this momentum topic. I'll give you the best of me. Please, please, please pay attention because you really need this. So let's just start with our lesson 1 before wasting any of the time. So here we are on lesson 1. So obviously one may want to know what is momentum, right? So momentum can be called mass in motion. So this is the mass in motion, that is momentum. But according to physics, the way that we want to answer that, we say momentum is the product of the object's mass and its velocity. That's how we can describe it according to physics. So this is the product of the object's mass and its velocity. So let's take a look at this. So we know that mass is a scalar quantity, and we know that velocity is a vector quantity. So it means that momentum will now become a vector quantity since we are multiplying a scalar with a vector. So how do we represent momentum mathematically? So momentum is represented by the letter P, which should be equals to mass of the object multiplied by the velocity, which is a vector. So that is mathematical representation of momentum. So since we know that mass is measured in kgs and velocity in meters per second, so it means that the SI unit for momentum will become kg per meter per second, like that. So let's talk about something that is really important when you're dealing. Check this, velocity. So we know that velocity is a vector. Always velocity has direction, magnitude and direction. So which will make this also a vector quantity. So now momentum, so this momentum will take the direction of the velocity. It will take the direction of the velocity. So always remember that when you are dealing with momentum, direction is important. So you can take a note that direction is important. It is important. So now do we calculate this momentum, or how do we use this to calculate the momentum? So suppose let's have an example, right? A car is moving east at 10 meters per second. Maybe this car is 50 kg. A 50 kg car is moving east at 10 meters per second. So according to this situation now, it means that simply momentum of this car, it is mass multiplied by the velocity. So this is the mass of the car, which is 50, multiplied by its velocity, which is 10 to the east, right? So which makes the momentum of this 500 kg per meter per second east. So when you're trying to calculate the momentum in the situations like this, it becomes way simple, just like that. Maybe let's take another example before we can move to the core importance of this topic. A 5 kg ball is kicked west at 18 meters per second. Find the momentum of this ball. So you write your formula down. So you know that momentum is equals to mass multiplied by the velocity. So what is the mass that we are having? It is 5 kg, and the velocity it is 18 meters per second west. So this is moving west. So now you can punch that in your calculator. So it means that your momentum is equals to 90 kg per meter per second. The direction of this, it is west. So momentum also take this direction as west. So that is how we can calculate the momentum, just the momentum of an object. So always remember that momentum is a vector quantity. It has magnitude and it also has direction. And also remember the SI unit, which is kg per meter per second. And always remember that this is very, very important when we are dealing with this topic. So now let's move to a bit of challenge when we are dealing with momentum, right? So in the first part of this lesson, we were talking about momentum. So we're talking about momentum of objects with constant velocity. So with constant velocity, it means that the velocity wasn't changing, it was remaining the same throughout, right? So now we are going to be talking about collisions. So collisions, they happen almost every day, almost every minute, almost every second of our lives. Collisions. So when a collision happens, the number of things that happens. So when collision happens, so what is collision actually? So collision So a collision is an isolated event in which two or more moving objects exert forces on each other. So when a collision happens, the following might happen. So when a collision happens, a body might change shape. So a body might change shape if maybe we are having body A here colliding with body B here. Maybe they collide somewhere here. So what we know for sure is that a body might change shape. That's one of the things that might happen. Or we know that, sorry, let me use, oh, still it's fine. So a body might change shape. A body might change direction. So a body might change direction, and also energy can be lost. Or saved. It's one of the things. But what we know for sure is velocity of the object or the objects will change. So this is what we know for sure, that velocity of these objects will change. It's either they'll slow down, or it's either one of the objects will increase the velocity, right? So it's one of those. It's either velocity might decrease or velocity might increase. So one of those might happen. So now let's talk about when velocity of the object changes. So when velocity of the object changes, what happens now? So obviously we said momentum is mass multiplied by velocity, right? So it means that if we are having an object A there, right, and then it collides with something and velocity changes, so it means that also the momentum will change, right? Also the momentum will change. So mostly we separate the situations of these objects as before or after the collision, right? So maybe this object was moving and then it collided here, and then maybe it continues to move but with less velocity. So this will be before the collision, or we can just represent this as initially. And this will be after the collision, so mostly we represent as final, like that. So it means that this object, since it collided, the velocity changed, right? So it means that also the momentum changed. So we have the situation where we are going to have momentum of the object initially. So this is the mass of the object and the velocity initially of the object before the collision. Before the collision. So when we are saying initial, we mean before the collision happened. And also this object after the collision, now it will have the momentum again after the collision. So this is the collision. So it means that after the collision, this will still have momentum, but it will be different with the final velocity. The final velocity is different from that. Like we said, velocity of the object will change. So now we are accounting for that change. So the change in momentum of this object, now we can calculate the change in momentum as, so we show the change by this. So the change in momentum is equals to momentum final minus momentum initial. So change in momentum will become this and that, and we can also expand these formulas as mass velocity final minus mass velocity initial. So now we like to understand that or we like to assume that the mass of the object didn't change. The mass of the object remained the same. So it means that the change in momentum will simply be the same as mass, final velocity minus initial velocity, like that. So this is how we can find the change in momentum of an object. So now we are on change in momentum. So we said change in momentum happens after what? So change in momentum this happens after a collision and velocity of the object changes, then so does its momentum. So it means that to calculate change in momentum, we can use any of these formulas depending on the situation that you are having. So change in momentum is equals to momentum final minus momentum initial, or change in momentum is the same as mass velocity final minus mass velocity initial. And change in momentum as well is the same as mass velocity final minus velocity initial. So now I will talk about something that is very, very important when we're dealing with this now. So remember on the first section when we were talking about just momentum, I didn't talk much about the direction. I was just choosing the direction, or I was just taking the direction after calculating the momentum. But now, before this calculation of finding the change in momentum, we have to do something we used to do on vectors, right? So if you're not that good with vectors, you can go back to our grade 11 playlist. I'll show it there. You can just go and rewatch how the vectors work. So now you have to choose the direction before the calculation. Choose the direction. So how do I mean by choosing the direction? So as we know that the change in momentum, or after the collision, when the velocity changes, sometimes even the direction changes. So the object can also change the direction. I showed that the object might change the direction, right? So it means that to choose the direction before the calculation, it places you in a safe net. You know that you always get your answers right. Just for an example, we can have a situation where something was going to the right, and then after the collision, it bounced back and starts to move to the left. So it means that this was our initial velocity and this is our final velocity. So it depends on you, what do you love to work with? So since we're talking about right and left, so it means that before your calculation, you can start right away by saying, let my right be positive, which will mean that anything that is going left will be negative. So that will already place you at the safe place. You will never get your answers wrong. Let's take a look at these examples. Then you understand how to use these directions in your favor, right? So let's take a look at this example. They said a 800 kg car was involved. So this is the mass. Was involved in a collision. So we know that there was a collision there when it was traveling at 20 meters per second west. So initial velocity, it is 20 meters per second west, and it bounced back at 10 meters per second after the collision. That means that our final velocity will become 10 meters per second east. So before attempting the question now, so now you have to choose the direction which direction do you like working with, as positive or negative, right? So we have west and we have east. So we can choose our east as positive and our west as negative, right? So there's no wrong answer for choosing the direction, right? You can choose any direction howsoever you want, as long as the two directions are there, right? So the other one will be positive, the other one will be negative. So now to calculate the change in momentum now, it means that we can say change in momentum, and you can use one of those formulas the way that you want. So in this case, I used this one, minus V initial. So it means that my change in momentum will become my mass being 800 kgs. So since I said east is positive, so it means that this becomes positive and that becomes negative. So my V final is 10, which is positive, and minus for the formula, and this negative 20. So this will become 800, and then 10 minus 20 just becomes 30, like that. So the change in momentum becomes 24,000 kg per meter per second. So since this is positive, and we said our positive is east, so it means that our change in momentum will become east, like that. So after finding your final answer, you check the sign of your answer. If it is positive, you pick the positive and represent it there, and if it is negative, you pick a negative and represent it there. So that's how we can find the change in momentum, right? So now we can move to the final section of this topic, which is Newton's second law in terms of momentum. Newton's second law in terms of momentum. So in grade 11, we did Newton's second law. Newton's second law. So Newton's second law, according to grade 11, say that if an unbalanced force acts upon an object, it will cause the object to accelerate. So this object will accelerate in the direction of the unbalanced force, with the acceleration directly proportional to the force, and inversely proportional to mass, right? So which mathematically we were representing this by saying F net is equals to mass by acceleration, right? But now we are going to try to use this in terms of momentum now. So how can we do that? So we know that this still our F net is equals to, we know that acceleration is change in velocity over change in time. So this can be the mass, and we can represent this by Vf minus V initial over change in time, like that. So which means that our F net is equivalent to mass multiplying Vf minus V initial over change in time. So can you notice this from what we're doing? Yes, this is the change in momentum. So which means that our F net is equivalent to change in momentum over change in time. Yes, that is equivalent to that. So now we can state Newton's second law now in terms of momentum, right? Newton's second law in terms of momentum. So this is that the F net acting on an object is equal to the rate of change of momentum. As simple as that. The F net acting on an object. So the F net acting on an object is equal to the rate of change of momentum. So still those directions, they still apply here. Don't forget that your VF and your V initial are vectors, and so they need the direction in order to find the F net correctly. So the F net acting on an object is equal to the rate of change of momentum. Since we said when collision happens, it means that the objects that are involved in a collision, they will exert a force on each other, right? So that force is equal to the rate of change of momentum of the object, right? So let's try to find a question where we can apply this. So it means that this, according to this, it's either we are trying to find the force acting on an object, or the change of momentum of the object, or maybe the velocity final or the velocity initial, or maybe the mass, while we are having the other quantities. So let's take a look at an example. So we are having a situation here. They said a 22-gram bullet strikes the target traveling at 320 meters per second. Strikes a target. So it means that towards a target, we can let this be positive. And since our mass is in grams, we can change from grams to kg. So it means that this will become 22 over 8,000 kgs, right? From grams to kg, we divide by 1,000, like that. And exits the target. So it exits the target traveling at 220 meters per second in the same direction. So still, it is still in the direction. So if we say towards the target is positive, so it means that this will be positive and also this will be positive, right? The bullet takes 0.00015 seconds. So this is our time that it takes to pass through the target. So the question, the first one says, calculate the bullet's change in momentum. So to calculate the change in momentum is not that hard. So we can say change in momentum is mass Vf minus V initial. So which change in momentum can become our mass, which is 22 over 1,000, being multiplied by the final velocity, which is 220, and it's positive since it is still going in the same direction, minus 320, which was positive as well. So it means that our change in momentum, we get negative 2.2. So this is negative value, right? So as we said, towards the target, it is positive. So it means that away from the target will be negative. So this negative shows us that our change in momentum is away from the target. So it means that our change in momentum will simply become 2.2 kgs meter per second away from target. As simple as that. So the next question, they said calculate the net force the bullet experiences, right? So to calculate the net force, we said F net is equal to change in momentum over change in time. So which will simply mean that our F net will simply be equal to, we saw that our change in momentum, it was a negative. So this will be negative 2.2 divided by the time, which is 0.00015 seconds, right? So it means that the F net acting on this bullet now becomes negative 14,666.67 newtons. But this negative is just showing us the direction. So it means that the actual force acting on this object acting on the bullet becomes 14,666.67 newtons away from the target. So this is the force that is acting on the bullet. So this is how we can deal with Newton's second law in terms of momentum. So I hope you are clear now in terms of all the sections that we did so far. So it means that on our next lesson we are going to be dealing with the law of conservation of linear momentum, and also we are going to deal with elastic and inelastic collisions. I hope you enjoyed. If you haven't subscribed, please subscribe so that this channel will keep on bringing you content that will help you to ace your exams. Until then, I'll see you on the next lesson. Have a lovely day.